If we're going to create or update an existing system in Thorium, we'll probably need to change the backend data. The way that Thorium gets the data for anything is through the GraphQL API, which means there will likely be changes needed to the schema. The schema lives in the server, source, typedefs folder, and we can see that there are files for every one of the systems and aspects of Thorium that need data from the server. There's a template up here which we can use to create our CRM system. So let's duplicate that. The template's pretty straightforward. It gives you a base type. It gives you extensions to query, mutation, and subscription, which you'll probably need. And it gives you base resolvers for the query and the mutation helper and a subscription update. So let's get everything necessary for the base CRM system. There's going to be a lot more stuff necessary to get this all working. There's a lot of moving pieces and a lot of complicated things, but for right now, we'll just have the CRM system. So we'll add that type. And since this is a system, there actually is an interface which we can use right here that gives me all of the fields necessary for a system. It's things that come built into a system. So let me just copy that, and we will add implements system interface here. And then I can paste in everything that already exists on a system so I don't have to type that in again. And then we can add any extra information that we'll need for the CRM. So let's take a look at our requirements, and we'll see that it has information about Vipers, has information about a password, so we can add that, whether or not it's activated. So let's start with those two things. Let's add another type for the fighters. In Thorium, every type should have an ID so that we don't have duplicates or collisions when Apollo grabs the data and is trying to cache it. Having an ID will mean that every item is always unique, so there's no collisions anywhere. Since each fighter is going to be linked to a client, we'll have a client ID as well. And then a couple of attributes about it, like its hull, which will be a float. It'll be from 0 to 1. Its shield, and whether the shields are raised. We'll have the phaser level, and the torpedo count, and whether or not a torpedo is loaded. Since it would be easier to just change a value instead of deleting the CRM fighter when it gets destroyed, I'll add a destroyed property as well. And there will be a docked property for when it's docked. And then finally, we need to track its position. Sometimes there are types that already exist. For example, I can search for type coordinate, and we'll find that it exists here in thrusters, and it gives me just an X, Y, and Z with floats, which is exactly what I need for the CRM. So we'll add that in for the position. Since the fighter is going to be moving, we'll probably want to track its velocity as well, and that can be tracked using coordinates. One thing that I forgot to include is an icon that should be selectable by the flight director, and that'll just be a string. The cool thing about this CRM fighter type is we can actually use it to model both the enemies and the fighters that are being controlled by the crew. So that's handy. Yeah, it looks like there are going to be a couple of other things that we'll need to include, such as the size of the target, and that'll be a float, the speed, and that'll be a float, strength, and that'll be a float, attacking, and that'll be a Boolean. Now that we have this CRM fighter type, we can include it on our CRM system. So let's add that. Fighters, and this will just be a list of CRM fighter, and then enemies. We'll keep them separate here, but that will also be CRM fighter. We'll just use the same type for both. Typically in Thorium, when we do a query for a system, we want to return a list of systems in case we feel like changing the front end in the future so that it supports multiple systems of that type. For the CRM, I don't think that's ever going to happen, and if it does, we can refactor this. So what we're going to do is make it so that the query returns a single CRM system. It will query it by simulator ID, but it's only going to return a single system. And then we just put the type that we created up here, CRM type, as the return value. And that'll be the same thing for our subscription. By convention, every subscription has the name of the query that it matches the data for. and then update at the end, and we'll still have that simulator ID here. Great. Let's write the resolver for our query in subscription. We'll worry about the mutation in a future video. So we have our CRM here. For GraphQL, the first parameter is going to be the root query, which we don't need to worry about. The second parameter is our arguments. So we'll grab the simulator ID out of that, and then we just need to return the data from app. I've already imported app up here, so it'll be really easy for me to get the data out of it. I just have to go return app.systems.find, since we only want to return a single one. We'll check the simulator ID first, and then we need to check and make sure that the class is the same type. Every class in Thorium has a class property on it that is just a string with the name of the class, and our class is going to be named the same thing as our type, so we just have to make sure that that is the same. Awesome. The great thing about returning a single CRM system in our query and subscription is that it makes it really easy to know if the subscription actually needs to fire or not. So let's add this subscription. It's the CRM update down here. The resolve function lets me transform it. Typically, with any updates that we do to the CRM system, it's going to pass the system itself as the root query, so I won't need to worry about modifying it at all. I can just pass the root query through the resolve function. And then with the subscribe, we need to make sure we update our async iterator to have the same name as the subscription itself. And then down here is our filter function, which we can use to see if a subscription actually needs to update based on data that's received from the publish function. So the root value is the value that we got from the publish function. Args is what we were passed in our subscription query up here. So that's going to be simulator ID. And then all we have to do is just check and make sure that our root value has the same simulator ID as the argument that we passed. Again, this will make sure that only clients that have subscribed with this simulator ID, they'll only get updates for the CRM system on my simulator. They won't get updates for any other CRM system, which decreases the traffic. Awesome. Now that we've written the schema, we can write our class, which will be in the next video.